So now here there's a question on a redox reaction. Okay, so say during a full gas scrubbing, sulfur dioxide, okay, can be oxidized while chlorine chlorine oxo species are reduced. Okay, then they're saying consider the redox reaction below and balance it in basic media. Okay, so we are balancing the redox reaction in the basic media. Okay, so what are the steps that we need to follow when balancing our redox reaction in basic media? Okay, so the first thing that we follow, we balance it in acidic media. We know that when balancing acidic media, we are going to be adding hydrogen and water molecules, isn't it? Okay, to balance in our oxygen, to balance our oxygen and hydrogen atoms. Okay, so we'll be adding hydrogen ions and water molecules to balance those two atoms, which are hydrogen and oxygen atoms. Okay, so that's what we are going to do. So you notice that when you balance it like that, it means that this will be in acidic media. Then we later convert it to basic media by adding both sides. We are going to add the hydroxide ion so that we have a basic media. So the same steps we follow when balancing our redox reaction in acidic media, we are going to follow them. Then we are going to add a one more step, which is adding hydroxide ions in both sides so that we convert our acidic media to the basic media there. Okay, so let's start. The first thing you know when balancing our redox reaction in any media, you need to identify the reducing and the oxidation reactions, isn't it? So you're going to check which species are being reduced and which species are being oxidized. Okay. So when we say oxidized, it means that you are losing electrons. We are becoming more positive. Okay. So if we are uh, to assign the oxidation numbers here, you notice that if you check the oxidation number for sulfur here, you notice that the oxidation number for sulfur in this molecule is going to be positive 4. Okay, in sulfur dioxide, the oxidation state for sulfur is positive 4. And then if you check the oxidation state for sulfur in the products there, you're going to notice that it's going to be positive 6, isn't it? So if we calculate the oxidation state for sulfur there, you're going to find that it's positive 6. Okay, so here it means that we are becoming more positive. If you are becoming more positive, it means that you were losing electrons. Okay, so if you are losing electrons, it means that here this species is being oxidized. Okay, so we can say that this has been oxidized to that, isn't it? Okay, and then if you check the other one, we are having chlorine oxide there, and we are having chlorine. Okay, so if you calculate the oxidation number for chlorine there in chlorine oxide, okay, you're going to notice that this is going to be the oxidation number there is going to be positive 5. Okay, and then for chlorine atom, it's a neutral atom. Okay, so it's having a negative 1 there. Okay, so if it's having negative 1, it means that the oxidation state is your negative 1 there. Okay, so it means that we are moving from positive 5, we are going to negative 1. So you are becoming more negative. And if you are becoming more negative, it means that we are actually gaining electrons. And when you are gaining electrons, we can say this is being reduced. The species that is gaining electron is being reduced. Okay, so that's the thing. First thing you need to do. You need to identify which species are being oxidized and which one are being reduced. After identify, you can come up with a two-half reaction. Okay, so one is going to be what we call the oxidation half reaction. So the oxidation half reaction is going to be composed of the species that have been oxidized. So in this case, the oxidation half reaction, you're going to get your sulfur dioxide there, okay, which is giving us SO4, 2 minus there. Okay, so this is on the oxidation half reaction. Also, you need to come up with a reducing half reaction. So I'm going to separate this into two. So I'm also going to come up with a reducing half reaction. So the reducing half reaction is going to be composed of the species that have been reduced. So in this case, you can see this guy here has been reduced to that one there. So we can write the half reaction, which is CO3. Okay, so we are having a minus there on top. So let me just Okay, so we're having a minus on top. And then this giving us chlorine. Okay, so it's being reduced to chlorine ion there. That's what we're having, right? Okay, so these are the two half reactions. Okay, so once you come up with the two half reaction, the next step that you need to do is to balance any other atoms apart from your oxygen and hydrogen. Okay, so if you're having oxygen and hydrogen atoms, you ignore them, but the first thing you need to do, you balance any other atoms apart from the oxygen and hydrogen atoms. Okay, so you can see here for the oxidation reaction there, we're having sulfur. So you check is sulfur balance. Okay, so you can see we're having one sulfur there, one sulfur there. It means that sulfur is balanced. Okay, we check on the reducing half reaction. You can see we're having chlorine there, one, also that side one. So it means that so chlorine is balanced. So the other atoms are balanced. Okay, so after balancing any other atoms apart from oxygen and the hydrogen, the next thing now, you come back for oxygen atoms. You need to balance your oxygen atoms. Okay, so how do you balance your oxygen atoms now? Okay, that's where now the issue of adding water comes in. Okay, so if you check here on the reactants, we're having two oxygen atoms, and then in the products, we're having four oxygen atoms, isn't it? So it means that we are lacking two more oxygen atoms this side. So for us to balance those two oxygen atoms, what we are going to do, we are going to add the water molecules the other side. Okay, so we will add the H2O. Okay, so how many H2O are we going to add? Remember, water molecules having one oxygen, isn't it? But we are saying we need two more oxygen. So we are going to add the two water molecules there. So if you add two water molecules, you notice that you are going to have two oxygen the other side, also two oxygen the other side. Okay, so it means that oxygen is balanced. Okay, but something fish here. After we balance our oxygen atoms, you notice that hydrogen has appeared. Okay, so we also need to balance this hydrogen. How do we balance the hydrogen atoms? Is by adding hydroxide ions. Okay, so you can see on the reactants we're having four hydrogen atoms there. So it means that on the products we're lacking four hydrogen atoms. So how we are going to balance those four hydrogen atoms is by adding four hydrogen ions. Okay, that's what we are going to do there. Then we would have balanced our hydrogen and the oxygen atom. Okay, so now after you balance the oxygen and hydrogen atoms, the next thing that you do, you would want to balance your electrons. Okay, so you check the summation of the number of electrons that you have in the reactant and also the number of electrons that you have in the product. Then you check which side is lacking electrons. Okay, so if we summate the number of electrons that you have in the products here, so we can see that here these are neutral atoms, isn't it? They have the summation of the charge as zero. So here we have zero. Also here we're having a zero. Okay, so it means that you have zero this side, isn't it? And then if you check the other side on the products there, okay, so you notice that here we're having a negative 2. Okay, then here we're having there's a 4 and positive there. So it means that we have a positive 4. Okay, so if you check your negative 2 plus 4, it means that you are getting a positive 2. Okay, so now we have a 0 this side and we have a positive 2 the other side. So what does that tell us? It tells us that this side is more positive than the left side, isn't it? The left side is less positive. You're having a 0. But the right side on the products there, it's more it's more positive. So this is less positive, this is more positive. So where there is more positive, it means that you have less electrons. Remember, electrons are negatively charged. So if you have a side which is less positive, it means that it is lacking electrons. Now, if you compare how many electrons should we add this side so that we also have equal number of electrons, which is 0. So for us to come up with a 0, it means that we need two minus, isn't it? So we can easily add two electrons this side to cancel out the positive 2 there, isn't it? Okay, so that's what we are going to do. We are going to add two electrons this side. Okay, so when we add two electrons, you notice that we are going to also have a net charge of 0. Then you would have balance your electrons. Okay, so that's on the oxidation half reaction there. So we'll do the same with uh, the reduction half reaction. So we've said any other atoms apart from oxygen and hydrogen, they are balanced, which is chlorine there. So we can check we have 1, 1, so it's balanced. So we need to balance the oxygen atoms. So how are we going to balance the oxygen atoms? You can see there, we're having 3 oxygen atoms. The other side, we don't have any. So we need 3 oxygen atoms. What do we do? For us to balance the oxygen atoms, we add the water molecules, isn't it? Okay, so we need 3 oxygen atoms. So what are we going to do? We're going to add 3 water molecules. So we are going to add 3 H2O. So you notice that in water molecules, you're having 3 oxygen there, isn't it? So if we have 3 oxygens there, and then even here we have 3 oxygen, it means that the oxygen atoms are balanced. But what is not balancing are the hydrogen atoms. You notice that after adding the water molecules there, we now have 6 hydrogen atoms the other side. So how do we balance these hydrogen atoms? We introduce the hydroxide ions. So we are going to add the 6 hydroxide ions, okay, to balance up the hydrogen atoms. Okay, this is coming from after adding water molecules. For us to balance the oxygen atoms, remember we are saying we need to add water molecules. Now, after we've added the water molecules there, we've noticed that here we're having hydrogens. Now, hydrogens have appeared. So we also need to balance those hydrogen atoms. So how we are balancing hydrogen atoms in acidic media is to add the hydroxide ions. Okay, so remember, we said we are balancing in basic media, but the method you are going to follow will balance in acidic media. Then later on, we convert it to basic media by adding hydroxide ions. Okay, so that's what we are doing. That's the reason why we're adding 6 hydrogen ions there to balance off the hydrogen atoms. Okay, so the atoms are balanced. The next thing you want to balance the electrons, isn't it? So if you check here, you submit the electrons. So here we're having a -1 there. Okay, so that on the left side, this side. So here there's a -1, and then here now there's a +6. Okay, so if you submit them, you are getting a +5, isn't it? So we do the same on the other side. So here we're having a -1. Okay, so that's the summation there, isn't it? This is a neutral molecule, so it will have a 0 charge. Okay, so the summation there is -1. So we have this side which is -1, and then the other side it's +5. So it means that this side, on the left side, we are lacking electrons. So how many electrons do we need for us to arrive at -1? So how many electrons do we need, okay, for us to get back to our -1? Okay, so you notice that we will need about 6 electrons, isn't it? So if we add 6 electrons, you notice that +5 plus -6 is going to give you -1, isn't it? So we need 6 electrons the other side. So we are going to add 6 electrons on the left-hand side there. Okay, so let's add the 6 electrons. So add 6 electrons like that. Okay, so we've balanced our electrons as well. Okay, so after you balance your electrons, now remember this is in uh, uh, acidic media, isn't it? But we are balancing this redox reaction in the what? In the basic media. Okay. So what we need to do for us to convert this to a basic media, we will need to add water hydroxide ions on both sides, isn't it? So add hydroxide ions on both half reactions. Okay, so let's start with the other one, this side. So we are going to notice that here we are going to add the hydroxide ions. Okay, so how many hydroxide ions are we going to add? Okay, so the number of hydroxide ions that you are going to add depends on the number of hydrogen that you are having. So here you can see we are having 4 hydrogen. So it means that we are going to add the 4 hydroxide ions. So we'll add 4 hydroxide ions this side. Also, the other side we also add the 4 hydroxide ions. Okay, so that's what we are going to do. So now, what are we going to have if we add 4 hydroxide ions there? What would be the half reaction that we are going to get when we add the 4 hydroxide ions? Okay, so we notice that here on the reactants, we're going to have 2H2O. Okay, then we have plus SO2. Okay, plus the hydroxide ions that we've added, isn't it? The minus there, right? Okay, then in the products, you're going to notice that you're going to have SO2 minus. Okay, then here you notice that once you have the presence of hydrogen ions and hydroxide ions, you notice that these two are able to add and form water molecules. So you end up having 4 water molecules there. So you have 4H2O. Okay, then plus the 2 electrons that we are having there. Okay, so this, we can rewrite this to be, so we are going to have, so now you notice that here we are having 2 water molecules, and then here we are having 4 water molecules. So we can cancel these water molecules this side. Okay, so we can cancel the 2 water molecules, and this side we can cancel 2 water molecules from here, isn't it? Since we are having them in the products, and the other side we are having them in the reactant. Okay, so we can cancel 2 of these water molecules. We subtract from the 4. So it means here we remain with 2 electrons, meaning the final half reactions, the oxidation half reaction that we are going to have, we are going to have SO2 plus 4OH minus, okay, giving us, then we are going to have SO4 2 minus, then plus, now remember we've subtracted 2 water molecules there. So we're going to remain with 2H2O, then plus 2 electrons here. Okay, that is for the oxidation half reaction. Okay, so let's do the same with the reducing half reaction. Okay, so the reducing half reaction that we are having is this one here. So we'll also do the same, we'll add the hydroxide ions. Okay, so we'll add the hydroxide ions. So here we notice that we are adding 6 hydroxide ions, isn't it? Okay, so you notice that here we are going to add 6 hydroxide ions. Okay, even the other side, we also add the 6 hydroxide ions. Okay, so plus 6 hydroxide ions. Okay, so what are we going to get when we add 6 hydroxide ions here? So notice that you're going to get, okay, so you're going to get 6OH minus, okay, then plus ClO3 minus, okay, then this is giving us, so here we are going to get Cl minus, okay, then plus, okay, so plus, what else are we having? We're having, okay, so plus the, okay, yeah, so here, remember we also had hydrogen ions the other side, isn't it? So even these hydrogen ions are also part of us. Okay, so we can say this side, the hydrogen ions and the hydroxide ions, these 6 hydrogen ions and the 6 hydroxide ions, they can combine to form 6 water molecules, isn't it? So we're going to have 6 H2O there. Okay, then we remain with the on the reactants, on the products, we remain with the 6 electrons plus the 6 hydroxide ions there. Okay, so okay, and then we also have 3 water molecules, isn't it? So we also have 3 water molecules. Let's not forget those 3 water molecules. Okay, so now we can also subtract there the water molecules. So we're having 6 water molecules on the reactants, and then we're having 3 water molecules on the products, isn't it? So this can cancel. Okay, so it means that here we remain with 3 water molecules. Okay, so meaning our final equation, the reducing half reaction is going to be, so remember we've subtracted, okay, so we are remaining with 3H2O, okay. Okay, then what else? We're going to have plus the CrLO3 minus there, okay. Then we also have plus, okay, so the 6 electrons, okay, so the 6 electrons were here. Then this is giving us, we're having, okay, so we're having on the products, we are going to have, since we've subtracted the 6 water molecules, we are going to remain with Cl minus plus 6OH minus as well there. Okay, that's what we have. Okay, yeah. Then now, we can also, we've balanced our half reactions. So the next step that I'll need to do, so we'll check the electrons that we're having on both half reactions. So we'll need to have same, the equal amount of electrons on both half reactions, isn't it? And remember, we've managed to convert it to the acidic media there. It's no longer, to the basic media. It's no longer an acidic media, isn't it? So we are having a basic media there. So what are we going to do? So we'll check the electrons. Remember here we're having 2 electrons, then there we're having 6 electrons, but we need to have same amount of electrons. So what are we going to do for us to balance those electrons? So we are going to add, or we are going to multiply this by 3 electrons, isn't it? 3, okay? Then this one will be multiplied by 1 for us to balance the electrons. Okay, so let's do that. So when we multiply by 3 there, we are going to get 3SO2, okay, plus, so here we are going to have 12, isn't it? We're going to have 12 hydroxide ions, okay? This is giving us, then there, 3 times that, you're going to get 3SO4, 2 minus, okay? Then what else? We are also going to get 2H2O. Okay, so this is 6. Okay, so that has to be 6. So we're going to get 6H2O. Okay, then plus, so there you're going to get 6 electrons. Okay, then here when you multiply with 1, we are going to get the same one, which is 3H2O. Okay, plus Cl or 3 minus, okay, plus 6 electrons, giving us Cl minus plus 6OH minus there. Okay, so we balance our 2 half reactions. Okay, so the next thing, you want to cancel the species that are common. Okay, so the species that are common will be looking at the reactants or this side, or the product of this side. You find the species which is going to be this side is also found in the product of the other one. Okay, so such species are going to be cancelled. Examples, you can see electrons here are in the reactants for this half reaction. Then the electrons there, the other side, they are in the product, so they have other half reaction. So it means that these electrons can cancel each other. Okay, so what else is common? Okay, so if you check the hydroxide ions, you notice that here we're having 12 hydroxide ions on the reactants, and then here we're having 6 hydroxide ions on the products there. So this 6 can go. It means that we remain with 6 hydroxide ions there, isn't it? So that's what we are going to have, right? Yeah. So we remain with the 6 hydroxide ions. Okay. What else is common? We check the water molecules. You notice that here we're having 3 water molecules. Here we're having 6 water molecules. So this can go. It means that here we are going to remain with the 3 water molecules. Okay. So now, after you cancel out the spectators that are common there, then you mix your 2 equations. Okay. So we are going to combine these 2 equations. So you notice that here we've remained with 3SO2, okay? Then plus, so we've remained with 6 hydroxide ions, isn't it? Okay? Then we've also remained with the Cl3 minus there. Okay? Okay? Then this is giving us, then the other side, you do the same. Okay? So you check what you've remained with. Okay? So here, you notice that you've also you're going to remain with 3SO4, 2 minus, okay? You're also remaining with the Cl minus there, and what else? Okay, and you notice that also here we remained with the three water molecules, isn't it? So you're having 3H2O. So that's what we are having there. So those are the things that you are going to remain with. Okay, so like this, you would have balanced your equation in as a basic media. You can see the OH there showing you that you are in the basic media. Okay, so if you want, you can counter check if you've done the right thing. So what you can do, you can check if the atoms are balanced. Definitely you notice that each and every atom here is balanced. You have 3 sulfur there, 3 sulfur, oxygen. Check the oxygen atoms are balanced. Okay, so here on the reactants you're having 6, then 12, and then this is 3, right? So that's 15. Then on the products you're having here, this is 12, right? Then you're having plus 3, that's 15. So the oxygen atoms are balanced as well. Check the hydrogen atoms. There are 6 here. Then this side as well, there are 6 hydrogen atoms are balanced. You also check if the electrons are balanced as well. Okay, so you notice that here the net electron that we are going to have on the left side on the reactants. So here we have a 0. Then here we have a negative 6, isn't it? So this is negative 6. Then plus this is negative 1, isn't it? That's what we're having. Okay, so if you combine there, you notice that you're having negative 6 minus 1, which is negative 7. Okay, so you do the same even on the other side. Okay, so you notice here you having this is okay, so this is negative 6. Okay, then this is negative 1, isn't it? Okay, then there you have 0. Okay, so this is negative 6 minus 1 as well, which is negative 7. So you can see even the electrons are balanced as well. So you would have confirmed that this is your final balanced chemical equation in the what? In the basic means. Okay, yeah. So you also have tutorial sheets which have been solved on this one. Tutorial sheet 2, stereochemistry. You can check it out. So let me just show you how you can access that toy sheet on our website. Okay, so okay, yeah, okay, yeah. So you can just open your browser. So when you open your browser, you search Discrete Learning Institute. Okay, so you can search Discrete Learning Institute. So you write on your browser, check Discrete Learning Institute. Okay, so you open like that. So if you don't have an account, it wants you to create an account and to enroll to the course of your choice. Okay, so once you do that, you notice that you're going to find an icon which is looking like this. Okay, so it will show the courses that you are enrolled. Okay, so here you can see this chemistry. So if you are enrolled chemistry, you can open the folder for chemistry there. Once you open the folder for chemistry, you can go where it's in general chemistry. Okay. Then once you open that folder in general chemistry, you go where it's in toy sheets and assessment. Okay. So you open there. Okay. Okay. So you choose the university. You can go to UNLAS there. If you're at UNLAS, you open. Then you're going to choose the semester you are in. Okay, so if you are in first semester, you choose first semester there. You open, then you are going to see these intakes. Okay, so you go for the current intake, which is the January intake. Okay, so when you open the January intake there, you are going to okay, so let me wait for it to load. Okay, so you're going to see folders for the tutorial sheets that you've been given so far, which is tutorial sheet 1, tutorial sheet 2, and tutorial sheet, tutorial sheet 3, 4, 4B as well. Okay, so the video solutions for these tutorial sheets are available. Okay, so for stereochemistry, if you want questions on the on balancing the redox reaction on acidic media, only, you can just go there where it's saying theory sheet 2, stereochemistry. You're going to notice that you are going to find all the recording, the video recording for the theory sheet. Okay, so here we are having the balancing of redox reaction in basic media, also balancing of redox reaction in acidic media. These are separately done. Okay, so that's what you do. Thank you so much.